Hello everybody and welcome back. Today we're going to talk about how to save your failing marriage. What? Oh, this is for the Super Smash Brothers video? Oh crap. Let's go over how we used image detection to determine that we were opening Smash and to send the command to turn on the taser. First, let's talk about the things we need to make this work. We need Python at least 3.6. There's just some libraries and stuff that need to have the 3.6 version or above. We need OpenCV, which means it's the open source computer vision. This is really the star of the show. It does all the image capturing and checking for matches and things like that. We use NumPy here. We use it just a little bit. Not overly important that you understand how that part works. We need OBS Studio for importing the video, and then OBS Studio Virtual Cam for creating a virtual, well, literally what it says, a virtual camera for a video feed. Now, you probably could do this without virtual cam, but I found that it was more consistent if I sent the video feed to a virtual camera when I was doing the detection. Alright, so here's our code. As you can see, it's not very long, only 36 lines. We'll go over this real quick. This is in Python, as we mentioned earlier. So Python is really important that you import the libraries that you'll be using for the project if they're not part of the standard packages. So CV2 is what the OpenCV library is called. So we're going to import that, and as we talked about earlier, we're going to use NumPy here. We're going to import that as MP just because we're lazy and I want to type NumPy. And as you can see, I only ended up using it once right here. So I probably could have left that as NumPy, but no big deal. So the first thing we're going to do is capture the video. So I'm creating a variable cap here, and I'm telling it to video capture. You see this 1. This is going to change depending on your system. My particular system, I had the actual capture device, which would have been 0 in this case, because computers start counting at 0. And then the virtual cam becomes the second capture device, which if 0 plus 1 is 1, so that's what it is. Then we set the resolution here, 128 by 720. This is the third and fourth property. I don't remember what 1 or 2 is. Doesn't really matter in our case. Then the template. This one's kind of important. So the way that OpenCV works is that it's going to look at the video frame by frame and then try to match it to a template that we give it. So in this particular case, we wanted to match the opening scene of Super Smash Brothers Ultimate. So this is a small cutout. Here's the actual full-size picture here. That might get cut off a little bit in OBS recording, but that's fine. So this is a 720p image of the opening scene, like right as everything fades from white into Kirby, looking out over the destruction here. So as you see, I cut off a little area here because just like your vision, you can't see the peripherals of your vision and things like that. The less information we give OpenCV, the easier for it is to find a match for things. So I ended up, and even you see how small this is, we actually in the code end up cutting out just Kirby here. But anyway, we'll get to that here soon. So we're doing a IM, which stands for image read of that template, and then I can't remember what the 0 is for. It's probably not important. The main thing is though that we're looking at this picture, and then I'm getting the width and height for the template, just so it knows how it's a 1280 by 720 size picture. Now this method here, this one is like some of the secret sauce to how OpenCV works. Now, there's a lot of math involved. I'm no mathematician. I'm going to show you some of this stuff. But essentially, here's the different types. There's 6 different methods you can do for template matching. What I ended up doing is just as I was going through the code, I just tried them to see which ones worked the best for me. Turns out it was this last one here, which again, look at all this math. I don't know what any of this means, but this is the, maybe some of you do, this is the sweet math algorithm that we use here. Yeah. Uh, Now I was doing it up here while I was testing. You can see this is actually a string. I have to eventually evaluate it down here to process that into an actual function. You could have, and I wouldn't do this, well, I guess I did anyway. You could have just done this and not had this part completely, but doesn't matter really. So a while loop in programming just keeps going until things break out of it. Uh, so this is going to run forever basically, and we want that because the video, we don't know when the video or when the template will match a part in the video. We don't know what the exact timing of that is, right? So it's really important that it runs forever until it finds it. So we have two variables here that are going to get cap.read. Cap.read, if you remember, cap is our video capture. Reading means it's actually going to look at the frame and save all that information into these variables. We set our method, the type of template matching we're going to be doing. Now this first image here is going to capture one frame, which we got from here, and it's going to convert it into grayscale. Earlier I told you that the less information we give the computer, the easier it is for it to detect things. So we're getting rid of all the color. We're just going to have shades of gray. And that makes it really easy for the computer to match things because the computer algorithms are numbers, right? Grayscale is the numbers from 0 to 1, with 0 being black and 1 being white. And any of the numbers in between are going to be the different shades of gray. Makes it way easier for it to calculate just shades of gray as opposed to having to calculate all sorts of colors. Then we're going to set the resolution, which is going to match the template here. No, it's not resolution. I don't remember what I chose res for. But anyway, we're matching the template here. The image, which is the frame that we just captured right here. The template, which again is the picture that we gave it. And the method. So basically we're asking, hey, for every frame, use this template and this method to see if we find something. The min-mal, max-val, min-locate, max location, these are important to tell OpenCV what we're trying to match. So again, this res function here is this template. We're basically saying, hey, all this stuff I did to this template, I need you to save all that into these 4 different variables. And the reason why we're doing that is because later we're using these to get some information. Like in this particular case, like the top left equals max location. Oops. And this max location thing from here, min max loc. It basically, there's a, I'm not going to go into it, but basically it's telling us where the upper left hand corner of the square we're trying to look at is, and all the other information about that sort of thing, about the area. So this is not super important, as when I was trying to do different things. Essentially, if you use these two, you have to use a different location. But since we're not, the max location is the top left corner of the screen. I don't really have a good visual aid for this, but you just have to trust me here. Bottom right is going to be the top left, which again, if you imagine a square, right? Actually, I guess we can just pull up that picture. So if we're trying to figure out where this is in code, if you take the top left, right, you add the width, so we go all the way over here, and then you add the height, which normally in programming well, it's either add or subtract, I don't remember. But regardless, we're going to use the width to determine where this is. So take the top left, add the width, add the height, bottom right hand corner. Essentially what we're doing. Yeah, so I add the height here. Okay, so this location, this is where we're using that the numpy here. I probably could have done this without it, but it would have just been more coding, and it's just easier to do this. And this res here again is the template matching, and the greater than equal to 90, this is a threshold. I had to play around with this, and I basically settled on 90 because 90 was close enough. It ended up not finding any other matches. This is just something you have to play with depending on what your video is. All right, so now here's another loop we're doing here. This is the loop where we are looking for the actual match. So I don't remember why I use PT or zip, but we're essentially PT is going to be our variable here for all the locations inside of this. What is zip again? I don't remember. I don't know. It doesn't essentially matter. We're basically going to be taking the rectangle of from the image, which again is our grayscale thing here, the top left. So we're essentially looking at this folder here, this photo here in black and white. Top left, bottom right, and then I'm actually adding some different variables here. I believe this makes it smaller, if I remember correctly. It's been a while since I wrote this code, but I think that part of the code ends up just looking here for Kirby. Once it finds it, it zaps them. Easy as that. This part isn't super important. This just allows us to visually see what's going on. You could actually not have this here and it would be fine. I did add a nice little thing here where you could press Q to quit. Now the only difference between my code and the code that you'll see in the video is that we change this print zap into an actual function that will press a key that sends the zap to the device. And yeah, this is just some cleanup code. It's not super important. Thank you.